Simon, and today we are talking about chromatography and color.
Yeah. What part of science is color in? Is it chemistry?
Physics.
Yeah, it's physics. Before we get to that, though, we have some very important business to get to.
There are only 3 winners, and I forgot their 3 names.
That's okay. So we had 3 entries from last week's activities, and we want to make sure that we have more people entering because we have very cool prizes available. So guess what we're doing this week?
Like shoutouts. Like shoutouts.
Like shoutouts, that's right. So guess what we are doing for last week's people who entered?
The prize winners are...
Yeah, how many are going to win a prize?
3.
Yeah, all 3 are going to win a prize. We have Logan, Caden, and Cameron, who all researched and did drawings of really gross parasites. Isn't that cool? Including the zombie ant.
Oh yeah, that one that infects ants, then it controls the ants, then causes it to bite down on a leaf stem, then it waits and dies, then long stalks grow out of its back or its head, releasing more of the like fungus or parasite thing.
That's right. So we have, we want to encourage everyone to do the challenges and win some prizes. All right, guess what?
What?
We have a whole bunch of people watching you already.
Okay.
We have Amy, RJ, Joseph, we have Parker and Wendy, Jaylene, Aaron, and Jaylene also says a big congratulations to all of the winners from last week.
Thank you, Jaylene. And congratulations to the winners if you're watching right now.
That's right. All right, so today is all about the physics of color.
And here are some jokes. What's a cat's favorite color?
Any guesses from our audience? It might take a moment for them to get in their guesses. So we can say, what is a cat's favorite color?
Purple.
Good one. Would you like to tell another one or wait?
What color is the wind?
Okay, let's get in all the guesses. What color is the wind?
Blue.
Nice one. Good. Good one. Okay, so Simon, we are talking about color, but we're also talking about physics. So can you tell how physics relates to color and how color actually works?
Okay.
Okay, well, I see you have something on your iPad here.
This is all visible light to the naked eye.
Well, these are all, they look like waves.
Yes.
So what type of waves exist in our world that we know?
Radio waves, microwaves, infrared, ultraviolet waves, which come from the sun mostly, X-rays and gamma rays.
That's right. So when things travel in waves, we can't really see them, except for a very small part.
Can we show the other picture on your computer?
Yeah, in just a moment though. So what can we see? We can see
light, color.
Yeah, we can see color. What is the difference, like why are there different colors?
Because how big their waves are.
Yeah, that's right.
And usually they're just only nanometers.
Yeah, it's measured in nanometers. How small or how big is a nanometer?
Like, nanometer is as big as 10 hydrogen atoms.
Yeah, that's just 1 nanometer. Yeah, so we're talking pretty small stuff.
Yeah.
Okay, so can you explain the difference in wavelengths in different colors? How does that work?
Purple has small waves. Red has big waves.
Oh, cool. And those wavelengths determine how our eyes see the colors.
I'm tired.
Yeah, it's a kind of a tired day today, isn't it? We did have some guesses for your jokes. We had guesses of black, blue. Blue was the right answer for the wind. What color is the wind?
Blue.
Blue, that's right. Okay, so we have some really cool activities today. We wanted to show you a prism, but we don't have a science prism. We have something else that's really cool.
This is something that acts like a prism.
Yeah, what is this?
It's a gift that one of my friends gave me.
Yeah, that's right. And it's a crystal, and it acts as a prism, and when it hangs in our window,
it collects the sun's light and makes rainbows.
That's right. It separates it based on the wavelength. So we tried to recreate that with a flashlight. What happened?
And the result is just a weird flashlight shape.
Yeah, it did not create the prism colors.
But it made a cool shape.
Yeah, it made a really cool shape. So how come it didn't recreate the colors of the rainbow, though?
Because it's a different type of light.
That's right.
Not UV light, it's whatever light.
I think it's LED lights. Yeah, but when
Red light.
yeah, but when we actually have this in the window with sunlight, it creates rainbows all over our walls, and this decoration acts like a prism.
And sometimes on our table and floor.
Yeah, sometimes on our faces.
Yeah.
Sometimes. Okay, we have some cool activities to show you. So the first activity is called what?
Milk.
The first one we're going to do is...
Chromatography?
Yeah, chromatography. That's such a cool word. Can you say it again so everyone understands?
Chromatography.
Chromatography. So look at, we have some stuff here set up for chromatography. Can you tell how this works, Simon? What is all of this?
So you pick a color that's not a primary color, and then you fill it with hot water. Hot water works best. And then this sucks up the water and then separates the colors that were used to make that color before the water touched it.
Yeah, so when we have things like markers, we have a whole pile of markers here. Some people don't realize that a whole bunch of particles or additives are used to make one marker color. So we want to find out what's in those marker colors. And to do that, we're going to separate the colors or the particles using chromatography. So what is this little setup? What's this paper?
Oh, coffee something.
Coffee filter paper. Yeah.
Coffee filter paper.
Yeah, so what we did is we just cut a strip off of a coffee filter.
Hat.
And created a hat. That is awesome. Okay, so what we're going to do is we're going to pick a color that we want to see the additives of what's in it. So Simon, what color would you like to pick?
I thought we already did some.
Oh, we want to do one in real time though.
Oh, okay.
Which color?
I'm gonna pick green.
Well, we have a green example over there.
Okay, I'll pick blue.
Okay,
Blue.
sure, sounds good.
Blue.
So let's see what's in blue. So make your dot.
Oh, that's already quite big.
Yeah, it is. And I'm going to just pour some water in here. It doesn't have to be hot water, but it does work better with hot water. Wait, don't put it in yet.
Okay.
We have to measure. So we want the very bottom of the filter paper to hit the water. So we need that to be measured properly. So that the filter will suck up the water.
My hat fell.
Yeah. We have a comment that was the hat of science.
Okay.
It was. All right, so we're going to make sure that this is just at the right spot. And look at, we don't have quite enough water in there. It's not touching the bottom of the water, so we will add a little bit more water. Can you take out the pencil, please, Simon?
Boom.
We'll add a little bit more of our water.
Boom shakalaka.
Okay, now let's see if it hits just the bottom. Oh yes, there it is.
Boom shakalaka. Boom shakalaka.
Now what we're going to start to see, oh, careful there, sweetie.
My hat.
We are going to start to see the filter water coming up over the colored dot.
And now it's turning like light blue instead of dark blue.
Yeah.
Do you want a hat?
I do want a hat, thank you. Okay.
What?
Yeah, keep watching. Let's see what's happening with this blue color. Now this does take a quick minute, but it does happen faster with hot water. Do you remember what this process is called again? What's that tricky word? It's a big word.
I forget.
Chromatography.
Chromatography.
Yeah, so let's check on this now. Look at that. So what's happening is the water is separating out all of those particles that were in the marker
It kind
color.
of looks like an upside down mountain covered in water.
Yeah. So because this does take a few minutes, we did some earlier to show you. Now, we did these about 20 minutes ago. Simon, what color was this one?
Oh, that was purple.
This one was purple. And look at, the water made the ink travel all the way up even over our pencil. Now, what colors do you see in there that made purple?
I see blue, pink, and dark purple.
Yeah, isn't that cool? And then we did another one here. This was the color green. And again, it traveled all the way up the filter paper, all the way to the pencil. And what colors were in the green marker?
There were green and blue, just green and blue.
Look at this one though. That's kind of,
Turquoise.
yeah, and I see some yellow in there too.
I like this one best. It's a heart.
Okay, so this is one we did last night, and do you remember what color marker this was from?
Black.
This was a black marker, and I like it because it turned out in what shape?
A heart.
Yeah, and look at all the colors that went into creating a black marker. What colors do you see, Simon?
I see blue, pink, and more black.
Yeah.
And a small hint of white on this side.
Yeah. Yeah, that's pretty cool. So let's go back to the one that we're doing right now, and let's see.
Okay.
I'm starting to see some different colors in there now. I'm starting to see a little bit of purple.
Yeah, me too.
And near the top edges, it almost looks like a little bit of pink is coming out.
Yeah. Pink, pink,
Yeah, that's pretty cool. So guess what we're going to do?
pink.
We're going to leave that to the side, and we're going to see if this chromatography is going to keep going and the water will keep moving up the filter paper. So we learned two tricky words though today. One is chromatography, which separates out particles.
And caterpillar action.
And caterpillar action. What's caterpillar action?
That's just what I thought of it.
Yeah. Do you remember the actual word?
No.
Capillary action.
Capillary action.
Yeah. So capillary action is when something sucks up water. So water is ascending or moving upwards against gravity. And that's because the water molecules are attracted to the paper or the fibers in the filter paper.
Can it go like bonded? Okay.
No, not right now, sweetie. So we have two more activities to show you that are really cool. The second activity also uses capillary action. Okay, so we're going to put that away. And Simon, you've got on your hat of science again. Can you show us the next activity that uses capillary action?
Bye.
No, leave those, leave those. Okay, what have you got going on?
Capillary reaction.
Yeah,
That's what's going on.
that is what's going on. Do you remember what this is called?
Capillary reaction.
What is this activity called?
Capillary reaction. Rainbow bridge.
Yeah, this is a rainbow bridge. What's happening here? Can you tell us what we did?
We did rainbow bridge. So what we did is, we put, I forget what it's called, but paper towel or something.
Yeah, paper towel.
We put it in between, each cup. Yellow is the most popular. And, we wanted to test, will it mix? And it seems like red is very slow.
Yeah, the red is going slow up the paper towel, but when it eventually meets yellow, what do you think will happen?
Mix.
And make what color?
It'll make orange.
Okay, and then what will happen on the other side here?
It'll make green.
Yeah, look at that.
And if they're all combined, I don't know what color it makes.
Well, we're going to find out. So this activity does take a little bit longer.
Okay.
And that's why we started it earlier, so that we could show you how it's done and so that you could try it at home as well.
Okay.
All right. We have one more cool activity to show you that has to do with color.
Okay. Milk.
Yeah. So we have a dish.
Milk.
And this is called, do you remember what this activity is called?
Rainbow milk.
Rainbow milk. All right. So we have a little dish.
Which has scratches.
Yeah, it has scratches in it. That's okay. Doesn't have to be a perfect dish. We have some milk that we're going to pour.
Tip.
Yeah.
Get in there. It's a swimming pool full of vampire skin.
Vampire skin.
Vampire skin is white.
Oh, that's true. So we also have some food coloring here for you, Simon. You can put a couple drops in different spots around the plate.
Boom, 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 boom.
Ooh, and guess what? Cameron and Caden are now here.
Arif wants to join the screen, I think. That's what he saw.
Yeah, I haven't seen that yet. So let's do different colors now. Okay. So maybe we'll actually be able to have a guest here on Facebook Live rather than through...
I bet, like we did with Dr. O.
That's right.
I wonder if we could have a
couple drops of red.
I wonder if we could have another visit with Dr. O.
I hope we have another visit with Dr. O.
Like another thing she's an expert at.
Yeah.
Boop.
Okay, and a little bit of yellow. Now this is a cool activity to watch how colors mix, but it's actually an activity about surface tension.
Yeah.
Yeah.
And here's how I learned about it. So I was doing an activity of how much paper clips I could fit in a cup, and which I think was a couple of scientists ago, and I saw that a tiny bit of the water was sticking out of the cup, but not falling. And that's what surface tension is.
Yeah. So this is an activity where we're going to break surface tension of milk. And how we're going to do that is we have our tray of milk and food coloring. We also have a little bit of dish soap in a dish. So Simon, you can stick your Q-tip in there, get it all full of dish soap.
I want to wreck him bone. That will sure make it break.
Let's see when you stick it in. Oh, what? Wait. I can't see. Your hand is on the different angle from the camera. So here, go ahead now.
Uh-huh. What? You're not afraid of me anymore?
Yeah, try it in different spots. Look at that.
Oh, look at what changed in the soap.
What changed in the soap?
It got brighter and some of it left.
Yeah, that's right. Do you want to try another Q-tip?
Yeah, sure.
Yeah, grab another Q-tip, dip it in the soap again.
Not a Q-tip. Q-tip. Q-tip.
And let's see what happens if we can do it again. Oh, the surface tension already broke. That is pretty cool, isn't it? You can make some really cool designs that way with colors.
Wait. I think I know what might work.
What might work?
I might actually be able to do this in a different way, but not have the surface tension break. Like put it in that thing where we put on paint, then we spin it around to see what it makes.
Oh, yeah, that is a cool idea. All right, so let's check on our chromatography over here again.
Cool.
We had a lot going on today. We had 3 activities going on today.
Cool.
So look at this. What did we notice with the blue marker?
It's starting to look like a waterfall.
It is starting to look like a waterfall.
And it's also going up, 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 up. Not the movie Up.
Not the movie Up. Do you remember what that's called?
Synonym.
No. Do you remember what this process is called where the water is ascending?
Capillary action.
Yeah, capillary action. That's right. So we have some comments and questions here. What is the first activity called again?
Chromatography.
Yeah, chromatography. It's also on the title of our video if you want to look up more ways that chromatography can work. Chromatography will separate the pigments that are found in our...
Pigments?
Yeah, pigments that are found in our marker. Just like this. And like this. So you can try using all different colors and see what colors actually are in them. Pro tip, cheaper markers work better. So if you have non-name brand markers, they work a little bit better. All right, so what's the next activity we did, Simon?
Rainbow bridge.
Yeah, there's a rainbow bridge over here to see if we can use that capillary action to mix colors. And what's the third activity we did?
Milky.
Yeah, rainbow milk.
Milky.
That's right. So we also have Cameron and Caden, and guess what? And Camille joined us too. So maybe we should do that announcement again because I don't know if they know.
Oh, okay. The prize winners are Logan, something.
Logan,
And I forget.
Cameron, and Caden.
Okay.
Okay. So what we would like to do now is tell everyone your challenge.
Do any of these 3 activities at home and then post a picture of it.
Yeah, we want to post a picture of any of these 3 activities. We're getting some comments that our Wi-Fi is a little bit glitchy today, so hopefully that won't happen again. I'm not sure why it would be, so we'll try to fix that. But yeah, we have 3 activities for you to try all about the physics of color.
Okay, bye. See you next time.